Okay, to finish up this problem, 90 minus 62 is going to be 28. Okay, so going on to the next problem, number 4, it says B is between A and C. So I'm going to draw a segment AC. And B is between them. Okay, B is not necessarily halfway in the middle or the midpoint. It just, unless it specifies, it's not always in the middle. Okay, so AB is 3x plus 13. BC is 6x minus 4. And the whole thing is 62. So I'm going to take these two equations and add them together. So let's do that. So I've got 3x plus 6x minus 4. And that equals 62. So I'm going to add together 3x and 6x, again, like terms. Okay, 3x and 6x is 9x. And then 3 minus 4 is negative 1. And then that's going to equal 62. I'm going to add 1 to both sides. So 9x equals 63. Divide both sides by 9. So x equals 7. Okay, now we need to plug stuff back in so that we can find what AB and BC is. AB, okay, that's a little on the light side. AB, I'm going to choose a different color here. AB is equal to 3x plus 3. So I'm going to plug in 3 times 7 plus 3. And that equals 24. Okay, and then that's what's going to go here. Okay, and then BC, the equation for BC was 6x minus 4. So 6 times 7 minus 4 equals 38. And that's what's going to go here. Okay, and if you add them together, we get 62. Okay, so number 5 says point P is an interior point such that AP bisects TAV, and if the measure of angle TAP is 3x minus 7 and the measure of TAV is 76, find the measure of TAP. So the big angle, go ahead and put that in this color, is TAV. Okay, and then there's going to be a ray, AP, that bisects it, meaning that it cuts that exactly in half. So each half is going to equal to each other. So they want us to find TAP, if TAV, the entire thing, so this entire thing, is 76. Okay, half of it, TAP, is 3x minus 7. So that's what's going to go here. Okay, and like on a previous problem, this bisects, so it cuts the angles in half, so both halves are equal to each other. So both halves are equal to 3x minus 7. So we're going to add them together, add the 3x minus 7s together. Okay, there's going to be 2 of them, so 3x minus 7 plus 3x minus 7 equals 76. I'm going to add the 3x's together, so I get 6x minus 14 equals 76. Then I'm going to add 14 to both sides, so I get 6x equals 90. I'm going to divide both sides by 6, so that x equals 15. Okay, and then we need to find measure of TAP. So measure of angle TAP. And if you remember correctly, the equation was 3x minus 7. I'm going to plug in x is 15 and then subtract 7 from it. And that should equal 38 degrees. Okay. Okay, going on to number 6. If M is the midpoint of AB and AM is equal to 2x plus 5 and MB is equal to 5x minus 13, find the expression that represents the length of x. We're going to go ahead and draw the picture first. So AB okay, and then the middle is M. And again, this is the midpoint, okay, midpoint. So we're going to call our M midpoint. Our midpoint is the M. Okay, AM is 2x plus 5. MB is 5x minus 13. Okay, and so since these are equal to each other, unlike the previous one where we had one of the halves missing, this has both halves. Okay, this particular problem has both sides or both segments. Okay, and so this equals that. Okay, so let me erase those marks, and then I've got 2x plus 5 equals 5x minus 13. I'm going to subtract 2x from both sides. Okay, so I've got 5 equals 2x minus 13. Okay, so I'm going to add 13 to both sides. So 18 equals 2x. I'm going to divide both sides by 2. Oh, sorry, I made a mistake. Let me go back and fix this. Okay, so this 2x that I had before is now a 3x. Okay, because it's 5 minus 2, which is 3x. Okay, so I'm going to add 13 to both sides. So 3x equals 18. Okay, then I'm going to divide both sides by 3. So x equals 6. Okay, but we need to find what AB is. So the entire thing is AB. So I can double whatever I get for one side and then and then use it for the other side too. So AB, okay, we can pick one of the equations and double it. Okay, so I'm going to double the equation by multiplying it by 2. Okay, and the equation that I'm going to use is the 2x plus 5. Okay, it doesn't matter which equation since they're both equal to each other. So again, I'm going to double it. I'm going to substitute in 6 for x. Okay, and that should give me 54. Okay, and then let me go ahead and box that answer, 54. Okay, so looking at number 7. Okay, let me erase some of these extra markings up here. Take away the 3s. Because we can see the problem here. Okay, so it says, given that H bisects, if you remember bisects means to cut in half. H bisects BTD. Okay, I'm going to highlight or actually just outline BTD in red. Okay, this is BTD. And it says if angle F is 26 degrees, this angle is 26 degrees. And then BT is perpendicular to TD. And then, yeah, so we're going to go from there. Okay, and then does it say anything? Yep, H bisects it. So that means these two angles are equal to each other. Find the following angles. Okay, so this is 90 degrees. Okay, that means that this other side is also 90 degrees. So I'm going to start by taking 90, because this is also 90 degrees over here. Let me highlight this. Okay, this angle is also 90 degrees. So I'm going to subtract 90 minus 26 to get the first angle. So that means that the angle in yellow is 64 degrees. So that angle is 64. Okay, these other two angles are 45 because H bisects BTD. Okay, so measure of angle E was 64. Okay, and the other two were 45 and 45. And I put the degrees, and that's typically what you're supposed to put there. I'm going to go back and fill those in. Okay. Number 8. Says, what types of angles are these called? It's called a linear pair because they are sitting on the same line. Okay, let me highlight that. Okay, they're sitting on the same line, and they create a straight line, and they also share a side. Okay, so they are supplementary, and they are also adjacent. So that's why they're a linear pair. Okay, let me erase that. Okay, so linear pair. Okay, also called supplementary. All right, so the equation that I'm going to use is the whole thing is going to equal 180 degrees. So I need to add those two together and set it equal to 180 degrees. Okay, so 3x plus 128 plus 5x plus 20 equals 180. I'm going to work the problems over here off to the side. So 3x plus 128 plus 5x plus 20 equals 150. Okay, I'm going to combine my like terms. Okay, so I'm going to combine this, and then I'm also going to combine the 128 and the 20. Okay, so 3x plus 8 is 8x. Sorry, 3x plus 5x is 8x. 128 plus 20 is 148. Okay, and that still all equals, and it's 150, not 180. Sorry, I put 180, didn't I? Let me correct that. Okay, so now I'm going to subtract 148 from both sides. So 8x equals 32. I'm going to divide both sides by 2. So x equals 4. Okay, number 9. Okay, so I'm going to go label my different parts of my angles. Okay, so MON, angle MON is 3x minus 30. Angle NOP is 6x minus 15. And the whole thing is 99 degrees. And MOP is 99 degrees. Okay, so I need to add together what's on the inside and set it equal to what's on the outside, which is the 99. So the two equations on the inside, 3x minus 30 plus 6x minus 15 equals 99. I'm going to combine like terms, so I'm going to add the 3x and the 6x, which is 9x. Okay, then I'm going to do the negative 30 plus the negative 15, which is equal to minus 45 or negative 45. Okay, and that still equals to 99. Okay, you see I color-coded the parts that you combine. Okay, so the blue is equal to, that I added together, and then the red I added together. So I'm going to go ahead and add 45 to both sides. So 9x equals 144. And if I divide both sides by 9, I get that x equals 16. So I need to go back and substitute in the 16 into these equations, okay? So the first equation is 3 times 16. I'm substituting it back into the original equations. So that first one is 18 degrees. Okay, the second one, angle NOP, okay, I'm substituting the 16 in again, is 81 degrees. Okay. Okay, so it says use the distance formula to see which length is longer. Okay, so the distance formula, I'll go ahead and make this a little bit bigger so we can see it a little bit better, and I'll graph it a bit too. Okay, so the distance formula is going to be, see, I'm going to run out of room here. Okay, I'll write it up here in the corner. And I'll try to write as small as I can. Okay, distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm going to plug in, I'm going to do AB first, okay, AB. Okay, and I'm going to subtract these two x values from each other first and square them. And then I'm going to subtract the two y values from each other and then square them. Okay, I'm just plugging those into the equation. So actually, I'm going to label them. Okay, the thing is, though, I have to change it whenever I use CD. Okay, and I'll show you that in just a second. So I'm going to use this equation right there. So AB, square root of x2 minus x1. Let me see if I can make this a little smaller so I can try to fit everything on the page. So x2 minus x1, x2 is 0, x1 is 6. Square both of those. Okay, and then y2 is negative 2, and y1 is 6. And then you square both of those as well. So this is going to give me a negative 6 squared plus a negative 8 squared. So that should be 36 plus 64, which gives me a square root of 100, which will equal 10. Okay, let me fix that. Okay, and then that's AB equals 10. Okay, I'm going to do the same thing for CD, but I'm going to kind of make it a little shorter so that way I can conserve some space because I'm kind of running out of space here. Okay, this one I'm doing the same way. I'm going to erase these x1s and y1s. Okay, and this time, this one's x1, y1. And this one is x2, y2. It's kind of writing all over the place, but... Okay, and I'm just going to subtract them from each other and go from there. So basically, that's 3 squared after I've subtracted the x2 and x1. Plus y2 minus y1, which is 0 and 4. So that's 4 squared. And after I've solved it, well, let me go ahead and solve it out. That's 9 plus 16. That's a square root of 25. So that equals 5. And that would be for CD. And then I'm going to go ahead and graph it. So let's go ahead and graph AB in, let's go ahead and graph point A. So it's going to be negative 6, 1, 2, 3, 4, 5, 6, up 6, 1, 2, 3, 4, 5, 6. Okay, that's point A. Actually, I probably should change color with that. Point B is 0, negative 2. Point B, okay? And that's going to be the distance right there. Okay, and so basically we just found the difference between, the difference here is going to be 8 and the difference here is going to be 6. And that's kind of where the distance formula comes from, okay? All right, so let me go ahead and draw the other one real quick, the C and the D. So C was 1, 4. Okay, and the D was 0, 4, 0. 1, 2, 3, 4. Okay, and then again, the distance formula kind of takes into account the 4 and the 3 there. Okay, so it says find the midpoint of AB. Okay, so I'm going to go ahead and go back to, I'm going to erase these x1s and x2s because this time I'm going to change it to go back to the original because we're going to find the midpoint. x1, y1, x2, y2. The midpoint formula is m equals x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay, so I'm going to plug in the numbers that I have. I've got negative 6 plus 0 divided by 2, comma, 6 plus a negative 2 divided by 2. And that should give me negative 3, comma, 2 as my midpoint. Okay, number 12. Okay, so it says C is perpendicular to B. So that means that these both create 90-degree angles. Okay, and actually let me redraw that so it's not writing all over the page. Okay, so this is a 90-degree angle. Okay, so angle 1 and 2 are complementary because angle 1 plus angle 2 equal to 90 degrees. Okay, and they're also adjacent. I'm going to have to write that above because I'm out of room here. Adjacent. Let me see if I can slide this over a little bit, actually. Yeah, that helps a bit. Okay, so complementary and adjacent. Okay, so angle 3 and 5 are vertical angles, sorry, not vertex angles, vertical angles because they're across from each other. So vertical Okay, angle 3 and 4 are linear pair because they equal to 180 degrees and they're also adjacent to each other and they're also supplementary. All right. Okay, so it says, what is the intersection of plane BCDA? Okay, so we're talking about the top of this box here. So let me highlight. We're talking about the top of this box. And then we're talking about the side of the box, GF. Oh, sorry, the bottom of the box, not the side of the box. Okay, and then the bottom of the box. So the top and the bottom I have highlighted in yellow. GFC. Oh, sorry, I've got it wrong, don't I? Okay, it's actually the back of the box that we're talking about. So let me highlight that in blue. Or blue. Okay, so GFCB, and that's the back of the box here. Okay, that's what I've got highlighted. So those two intersect at BC. Okay, see that line or that highlighted line is where they intersect. They intersect at that segment BC, so BC. Okay, name 4 lines that contain the plane ABGH. Let's erase all this. Okay, ABGH is the side of the box. Okay, and I'm going to basically get all the lines, or get all the segments that go around it. Okay, and so AB is one of them. Okay, and then BG, which is in the back, BG. Okay, and then on the bottom, okay, let's erase that, HG. Okay, and then finally the one in the front, which is AH. All right. Okay, so it says HGEF So HGEF is the bottom of the box. And then are points collinear or coplanar? So we're talking about these points, H, G, E, F. Those are all coplanar because they're all on the same plane. They're not all on the same line.